Okay, so in the last video we saw how to read data from a client, right? We saw how to read the data from the client, from the server into the client, right? So now we are going to see how to write the data and read simultaneously. So we are already reading some data from the client, from the server. Okay, so the client is already reading from the server. So these we are reading MW0, MW1, MW2 and MW3 from to our reading this data to our server, so to our client, that is the MicroLogix 1400. Now we are going to see how to read data, write data simultaneously. For writing, what we will do is we will use the same 4 registers. We will use the same 4 registers, MW10, MW11, or we can use an animation table to see. Let's see how that happens now. Let's make this big, make this full screen, close it, go offline. So for now when I want to write, so when I read the value, I used one message instruction, right? I used one message instruction. Similarly, when I'm writing a value, I need to create another message instruction, because in Modbus, one command can be only used, like you can say only one command can be executed at a time. So for example, when I'm trying to read the holding register, I cannot write to it at the same time. I cannot write to the holding register at the same time. So this will become a problem. So for that, what we do is we normally schedule the message when it should trigger. We will normally schedule the message for when it to trigger. So when we have only 2 instructions, so for example, I want one more message instruction. Let's create a timer. Let's change it to a message instruction. Okay. So now I put the same time base here. Okay, I will put the same time base, but in ANSI, so that it alternatively works. So when the time base is on, the first message instruction will execute. When the time base is off, the second message instruction will execute. So I need the second message address, message file mg9:1. So in the setup screen, so I'm going to set up the same thing as usual, integral Modbus TCP. But here, instead of reading the holding register, I'm going to write multiple register, because I'm not going to write just one data, I'm going to write multiple data. So if I put, see for example, write single register, you see, that's it. So you'll be only able to write to one address. So it's better to always put it into multiple registers. So because we are going to write into multiple registers, so it is asking for a data table address. So I will give N7:10. So then the size in elements, I'm going to write 4 elements. I'm going to write 4 elements. Okay. So if you can also change it to 32-bit if you are going to send a floating point value or something like that into the Modbus register. So in Modbus there is no 32-bit registers. If you are going to use 32-bit registers, it combines 2 16-bit registers together. Okay. So let's say 16-bit itself for us. So here the routing information can be the same, because the IP address is same for both the for both read and write. So I'm not going to create a separate routing information file. I'm going to give just RI10:0, because the address is same. The IP address is same, 168.0.18. Okay, it's going to be same. So here the Modbus address to which I'm going to write is going to start from 10. So you remember that MW11 is starting from here. MW10 will be starting from 11. MW10 is going to start from 40011. So I have to give here as 11. So you can see it changed to 11 here, and the unit identifier, the instruction address, let's put it 2, because this is a second instruction. So this is the first instruction, we put the unit identifier as 1. So here I'm going to set it as 2. Okay. So let's close this and let's just compile it. Okay. So there is a error. Let me so routing information completely overlaps another message instruction routing. The previous routing information will be overwritten. Okay, 192.168.0.18. This should not be a problem, but this is an error. Okay, let me just do one more thing then. This is 2 different instructions, but it should work. 1 second. Okay, let me try to download. It should not be a problem, because it will download. It is showing an error. It's download. It is just saying like it will override the routing instruction. That's it, but it does not matter for us. This is just like a warning, but it's still an error, but it's okay. But if you don't want to get this error, you can create a secondary routing information. Okay, now let's open the same thing here. So now let's say I want so now the problem what happened was I am writing to the value. So let me open N7 now here. You can see N7 10 11 12 and 13 is here. So whatever value I give here is will write to MW10, which will in turn get read into MW0. So if I give 5 here, it will get written into 5 there. If I give 10 here, so the PLC, the Schneider PLC will accept the 10 and it will move to MW1, which is MW1 here. So I'm just simply playing with this here. So 11 will become 11. So I say 756. So it will become 756 because here the 756 will be written. So then the 756 will be moved into MW3. Or you can even use a mod scan instruction to write this functionality. It's not a big problem. So this is how you write multiple registers into a slave device from the server. Sorry, from the client. So from here the client is the Modbus master, and the server is the Modbus slave. Okay, so you can read any number of devices like this, but as I recommended, if you are going to read like intermittent files, okay, 10 you need to read 10, then there is a gap of 2 and you have another 10. So it's better to read the 22 together instead of putting it as 2 different instructions when you are reading. Let's keep all the read holding registers in one instruction, maybe all the read coils in one instruction, all the read contacts in one input contacts in one instruction. You can do it like that. That is much better. That is much better. Okay. So since this is Modbus TCP, the data transferring is very fast. In 485, it depends upon the polling date of the program. Okay. So if I increase the time base here, like for example, if I decrease here and if the time becomes more slow, this response also will change. Okay. So you can see it is now immediately responding. So this is how you use Modbus TCP write function for multiple registers in Allen Bradley MicroLogix 1400 PLC. Okay. So in the coming videos, we will see how to do Modbus 485 in MicroLogix series PLC. Thank you.